सिर्फ ये होना तो भी चलेगा, सिर्फ क्रोम को ओपन रहना।
ये ले रहा है, it's crashing. Why it is crashing? नहीं तो ब्राउजर,
अगर सिर्फ ब्राउजर ओपन रहेगा तब भी होगा।
ये ट्राई कर रहा हूँ मैं।
पर ये सिर्फ मीट को लेगा शायद, मीट को ही लेगा, बाकी सारे विंडोज नहीं दिखाएगा। G-Tite बोर्ड वीक 6
बहुत हैंग कर रहा है स्टॉक, आई डोंट नो, हिल नहीं रहा है ऊपर सर, इतना कभी नहीं हुआ मेरा। कुछ तो गड़बड़ है, चाहे ओवी स्टूडियो बहुत ज़्यादा ले रहा है। क्या हो रहा है पता नहीं।
रिकॉर्डिंग स्टार्ट है क्या?
हाँ,
अगर किसी भी तरीके से हो रहा है तो होने दो।
it's crashing. Crashing like it's crashing like hell. नहीं कर सकते हैं। ड्राई स्क्रीन,
बस माइक ऑन करते हैं।
माइक ऑन।
I don't take full screen mode.
Try.
So may we start right now? Am I audible? Okay.
बहुत slow है।
Okay. So welcome to the course of signal processing for millimeter wave communication for 5G and beyond. And this is the assignment for week 6 here. So the first question is, which of the following technique may be used for creating pencil subbeams at the antenna? So the thing is, why do we need the pencil beams like in millimeter wave? So let me conclude it. So as we know, if it is a transmitter side antenna for a millimeter wave communication and there is a receiver antenna, so the reason of pencil beams is, if I do transmit from an isotropic antenna here, so if it is an isotropic antenna, it will radiate in the all directions in the same with the same power. But as the distance increases, the power decays for millimeter wave, as we discussed in the earlier classes. So we always try to do the sort of thing like pencil beam sort of things. So how these pencil beams works? Pencil beams are not like isotropic antennas. They just direct the beams toward the receiver antenna. Okay. So uh, am I audible? Okay. Is the board there?
But
Record.
display also there. But the recording
Yes.
is record from the screen only.
So the pencil beams are like this. It should not be like radiating in all the directions. This is sort of pencil beams, like it is the transmitter side antenna, this is the receiver antenna, and the pencil beams will be depending on like this. So if we use like the reason is, let me write the reason why do we need the pencil beams. Because for the millimeter wave communication, the power decay is very high. It is very high. So this is the motivation we are using pencil beam type of things. So what we do not use only single small isotropic antenna here. In case of one single isotropic antenna, we use here multiple small isotropic small antennas in a with a particular uniform distance. Like we take like this is our antenna structure, and this is the first antenna, this is the second antenna, this is the third antenna, and this is the fourth antenna. So they are fed by one signal here coming, it is here. So the electric field that is generated from the some amplifier type of thing, that is coming from the first antenna, and after every antenna is distance at a distance of d. So what happens with this sort of structure, as I had discussed, we can get the electric field like this. Er is equal to E0 into 1 plus e to the power j phi, and this phi depends on the factor 2 pi by lambda d cos theta, where lambda is the wavelength and d is the distance between these antennas. So for this sort of thing, so the actual real part of the electric field that can be described by uh, it's not working again. That is real part of the electric field that can be written as E0 into 1 plus cos 2 pi lambda d cos theta. And if we plot it in the polar plot, the beam pattern comes as this. So why this comes like this? Because if we plot the theta parameter in this direction, and theta varies from 0 to pi, and there is a cos term here. This term is some sort of periodic. So suppose at this term it gives a peak, and after some time it another gives a peak. So these peaks correspond to this and these peaks correspond to this. So for pencil beam structure, what we use, that is we use this increasing number of antennas. If we increase the number of antennas, we can match the phase depending on the term phi, and that is the reason The option A is the correct. Why we cannot increase the signal power continuously? We cannot use increase the signal power continuously just because like they are getting fed from the same electric amplifier, right? So the same electric amplifier is providing energy to each of the antennas. So only the thing we can manipulate, that is the phase, and with this phase manipulation we can create the particular directed beams, and that's why the only thing we can do is increase the number of antennas so that we match the phase of the electric signal such that it creates a sharp pencil beam, not a isotropic beam. Like we are using multiple isotropic beams and just adjusting the phase of them to just create a pencil sharp beam. So the right option is option A for question number 1. So the next question is, there is a ULA and that is set up on the Z axis and the antenna spacing is 0.5 millimeter. So the question is asked that what is the position vector of the fourth antenna element is given by. So let me discuss this problem. So this is question number 2, and the ULA structure that is given here is like this. This is the X direction and the above direction is the Z direction, and there is another direction Y. I will draw it. So the question is asked, there are 4 antennas there and the distance between each antenna is 0.5 millimeter. So we will arrange the antennas at 0.5 millimeter distance. So if we arrange them like that, कनेक्ट करके लिख सकता हूँ. रिकॉर्ड नहीं होगा, ये दिक्कत है. होगा. So this is the antenna spacings in the Z direction and this is the Y direction. This is X direction and this is Z direction. So there are 4 antennas. First antenna is placed at this place, second antenna is placed at this place, third antenna is placed at this place, and the fourth antenna is here, and each of them has a difference of 0.5 millimeter. So this is at Z axis 0, the next will be at 0.5, the next one will be at 1, and the third one will be at 1.5. So this is the fourth antenna place and this will be at 1.5 millimeter. So for question number 2, the correct answer will be option number C. The fourth antenna will be placed at 1.5 millimeter in the Z direction. So am I audible right now?
No.
Hello. Hello. Okay. So the next question is question number 3. So the next question is question number 3 says there is a 2 cross 2 multi-antenna system where the transmitting antenna are placed on x-axis and received antenna are placed on z-axis, and angle of departure is theta 1 phi 1 and angle of arrival is theta 2 and phi 2. So assuming the channel attenuation factor alpha be unity, the antenna spacing is lambda by 2 for both transmitter and receiver. So the receiver side steering vector is given by, so we have to calculate what is the receiver side transmitting vector. Slide is not visible, right? Okay. Still not it is clear, right? Okay, it is clear, or so someone is saying it is clear, someone is saying it is not clear. So who is not? Okay. So probably that is okay, because I have also a network glitch, so I am asking this, like whether my screen is visible or not. Okay. Okay. So question number 3 is consider 2 cross 2 multi. So I have already discussed the question. So the thing we have to answer is what is the receiver side steering vector. So receiver side steering vector, and let me solve this question. And this is for a 2 cross 2 system. So what the information is given, angle of departure, that is theta dash and phi dash, like I can, it is given as theta 1 there, and what is given angle of arrival is theta 2 and phi 2. Do not take it as square, this is only theta 2 and phi 2. So, and what is given else, the channel gain is given. The channel gain that is given is alpha. So in the receiver side, what is the steering vector is air, and this air can be defined as, like, this is the channel gain, this has nothing to do with the nothing to do with this receiver side steering vector, and what is angle of departure, that is only the transmitter side thing, so it also does not have nothing to do with this steering vector. So how it depends on the steering vector, like if there is an antenna here and if there is an antenna here and the angle is the receive beams are coming like this, so probably this is the angle of arrival in this direction of theta, we can think, if we think of theta, and correspondingly it will be for phi also. So actually what will happen, we have to calculate the first thing, the first receiver antenna, and this is e to the power j into 0, and the second thing is e to the power j phi 1. So let us calculate the phi 1 here. What is the phi 1? Phi 1 is, as it is discussed earlier, 2 pi d by lambda, cos theta, and this is theta 2. Why theta 2? Because angle of arrival is theta 2. So what will be the actual vector? If it is 0, it comes 1, and the second factor, that is come theta 1, and it is discussed that lambda is equal to d by 2 in the question. Like, it is given that antenna spacing is lambda by 2. So let us replace this as d is equal to lambda by 2, 2 pi lambda by 2 by lambda cos theta 2, and it becomes pi cos theta 2. So the steering vector that comes is j pi cos theta 2. So the correct option is option number B here. So let us go to the fourth question. So fourth question is, we have a setup and transmitting antenna size and receiving antenna size are given, and the question is for setup 2. The question is, what will be the dimension of the channel matrix? The question says that I have some sort of receiver antennas here, transmitter antennas. This is the TX side, and this is the receiver side. This is the receiver side. Which one? The previous one. This one, right? So that is, I think this is B. So there is also receiver side. So there are 8 antennas in the transmitter side, and there are only 4 antennas in the RX side. So data model is y is equal to hx plus w here. So y is the vector of 4 cross 1, and x is the vector of 8 cross 1. So to match the dimension of these two, what should be the dimension of h? If h is a 4 cross 8 matrix, then the vector hx becomes 4 cross 8 into 8 cross 1. This becomes 4 cross 1 matrix that matches with the y. So the H matrix, that should have a dimension of 4 cross 8. So the correct option is option number C, 4 cross 8, for this question number 4. So let us go to the question number 5. The question number 5 says the steering matrix, and the steering matrix is formed at the receiver side of a 3 cross 3 antenna system is given by this format: 1 e to the power j theta 1 e to the power j 2 theta 1, and we have to say what is the structure of this matrix, like Toeplitz matrix, Van der Monde matrix, unitary matrix, and wizard matrix. So in this case, Toeplitz matrix means this Toeplitz matrix always repeats the same row elements. Let me discuss. So first let's discuss the structure of the Van der Monde matrix. That will be better for you. So what is Van der Monde matrix? This Vandermonde matrix has a structure of this. It has in the first column all the ones, and if it is the next column is x1, x2, x3 dot 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 xm, and it goes like this. The next element will be x1 square, x2 square, x3 square dot 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 dot, dot xm square, and it continues till x1 to the power n minus 1, and this becomes xm to the power n minus 1. So let us replace x1 with e to the power j theta 1, x2 is equal to e to the power j theta 2. If we replace like this, the matrix will come like 1 1 1 1, and only here are only 3 elements, so 1 1 1, e to the power j theta 1, e to the power j theta 2, e to the power j theta 3, and it goes like this: e to the power 2 j theta 1, e to the power 2 j theta 2, and this is e to the power 2 j theta 3. So let us go back to the question. The question is, this matrix follows this structure as we discussed here. So the correct option will be option number B. This is sort of Vandermonde matrix. So right option is option B. The next question is, the resolving power of an array depends on what? So first just comment what is the resolving power. The resolving power, it is the capacity to, so for of any detection system to fix so it is the capacity of any detection system to fix separately to close arranged object. So suppose there is one object and here is another object. So what should be the resolving power depends on. So the number of antennas we increase here, the more the beam will be more pencil sharp type of beams. So if we increase the number of antennas, it always depends how to identify these two different systems. So resolving power depends on the number of antennas. So the first option is correct. My voice is cut. Okay. So the resolving power says, am I audible right now? Like my voice? Okay. So the resolving power, it depends how can I identify like to closed arranged objects. Okay. So how can I fix separated to close arranged objects? So it will always depend on number of antennas. If we increase the number of antennas, the beam pattern will be more sharper. So that's the first reason. The second reason is spatial extent. It also depends on that, and also depends on antenna aperture factor also. So let us go to the question. So the resolving power of an array depends on, it should depends on number of antennas, the spatial extent it will also depend, and also on the aperture. So the right option will be the option number D, all of the above. So let us go to the question number 7. It says a communication signal model is given by y is equal to x plus w, and the spatial correlation matrix is given by, so again, yes, it is all of the above. So let us go to the question number 7. So here it is given a communication signal model is given by y is equal to ax plus w. So the question is, the spatial correlation matrix is given by what? So what do we mean by the spatial correlation matrix? Suppose this is the RX site, and these are two receiver antenna. So in the first antenna we are receiving the data y1, and the second antenna we are receiving the data y2. So the correlation between these two data, that is expected value of these two data. So what is the vector that is this contains y1 and y2? This is the received vector in the receiver side. This is y. So if we want to calculate the spatial correlation, this is equal to, what is the correlation between y star, because they are two different entities. Now let me solve this. This is because the first element gives the variance of the first element. The second is y1 and y2 star. Third is to star, sorry, y1 star, and this is mod of y2 star. So see, this element and this element, this is the, if we take the expectation, this is the sort of power that we are receiving in the first receiver side and second receiver side, and these two are the correlation between the first antenna and second antenna, and these are cross correlation type of thing, and these two are autocorrelation type of thing. So if we want to calculate the spatial correlation, that is correlation between y1 and y2, so that is r is equal to y star. So this is the option number A. So the question says find the odd one. So first statement is beamforming helps in improvement of SNR. Second option is angle of aperture and angle of departure is same for LOS communication. The third option is far field assumption ensures parallel rays for AOA and AOD. And the option number D suggests AOA and AOD cannot be distinguished by placing reflectors. So let us comment on the last option. Angle of aperture and angle of departure cannot be distinguished by placing reflectors. So angle of aperture and angle of departure can always be distinguished by placing some reflectors, because if there is same LOS communication, then the angle of aperture and angle of departure will be same. But if there is some reflector, angle of aperture and angle of departure will not be same. We can distinguish between them. So they will be different at that case. And if we think beamforming helps in improvement of SNR, obviously it helps, because we are doing the beamforming so that signal power conserves. Like we are not sending to isotropic antennas. So the right option will be option number D. It is the odd one, and this is not a correct statement. So the right answer is option number D. AOA and AOD cannot be distinguished by placing reflectors. So let us go to the last question here. The last question is, here is a channel matrix is given by H, and H is 1, 0.25, 0.25 and 1. So we have to calculate the eigenvalues of H. So how do we calculate this? So the only task, we have to calculate the eigenvalues of this channel matrix, and if we can find the eigenvalues, we know this matrix is a full rank matrix. Okay, so this matrix is a full rank matrix, and I can have a decomposition of this, that is eigenvalue decomposition, and we can express it as a diagonal form. So why? So the channel matrix is given, and if this channel matrix, we know from the SVD algorithm also, like this channel matrix will have a decomposition for which we can decompose it at U epsilon V star. Now here the question is given that it is 1, 0.25, 0.25 and 1. And question is asked if we can represent it in a diagonal form. What is the diagonal form? Diagonal form is this epsilon vector. And if we can express it in the diagonal form, so question is eigenvalue it is asked. So they are ensuring the fact this matrix is a full rank matrix. And if this matrix is a full rank matrix, it ensures it not only have SVD, moreover it has a EVD. What is EVD? EVD means we can represent this matrix H as U epsilon U star. Like for SVD, there are two different unitary matrices. The first one was U, second one was V. But if it has some sort of EVD decomposition, ensures it is a full rank matrix, then it has this sort of decomposition, U epsilon U star. So what is the main thing here? V star equal to U star here. And another property, the diagonal elements of epsilon are the eigenvalues of the matrix H. So the main task here remains, according to this question, what are the eigenvalues of the channel matrix. So if we want to calculate the eigenvalues of the matrix, Let us solve this question. That is h is equal to 1, 0.25, 0.25, 1. Let lambda be the eigenvalue. So if lambda is the eigenvalue, what is h of lambda is equal to lambda of some sort of x, where lambda is the eigenvalue and x is the eigenvector. So we can write h of x is equal to lambda ix, or h minus lambda I of x equal to 0. So if x is a non-zero vector, then this equation suggests determinant of h minus lambda I should be 0. So let us calculate 1 minus, the first is 1, 0.25, 0.25, 1 minus lambda into identity matrix 1, 0, 0, 1, and we have to calculate the determinant of this matrix. So it becomes determinant of 1 minus lambda 0.25, 0.25, 1 minus lambda. This is equal to 1 minus lambda square minus 0.625, and we say this is equal to 0. So if we solve it more, 1 minus lambda square, this becomes 0.625, so 1 minus lambda square, this is 0.625. So 1 minus lambda is plus minus 0.25. So it will have two eigenvalues for plus and minus values. The first value, if we take the positive one here, it becomes lambda equal to 0.75, for 1 minus lambda equal to 0.25, and lambda equal to 1.25 for 1 minus lambda equal to minus 0.25. The first eigenvalue is 0.75 and second one lambda is equal to 1.25. So the correct option according to these options is answer C, 1.25 and 0.75. So this is all for this session for today. So anyone has any more question? Oh, yes. This one, question number 2. This one, yes. That is, yes, that is, that is 5. Because the first antenna is at 0, the second will be at 0.5, third will be at 1, and fourth one will be at 1.55. Each is at a distance of 0.5 millimeter and it is set up on Z axis. So fourth will be at 1.5. Okay. Your voice is cutting. Question number 6. It is all of the above, right? Yeah, third one is option number D. D for ball. Okay, we'll meet in the next Tuesday in that case. अनुल्ला का लैपटॉप गया आज, पूरा गया, मेरा तरफ हो गया इसका लैपटॉप। समझा भाव? भाव मेरे बात सुनेगा नहीं ना तू? भाव भाव क्या कर रहा है? इसका लैपटॉप पहले ऑफ करना है, ठीक है? रिकॉर्डिंग ऑफ करना है, कुछ नहीं हो रहा है इसका लैपटॉप पे आज। पूरा हैंग। बस रिकॉर्ड क्या हुआ या नहीं हुआ यही दिक्कत है, अभी भी रिकॉर्डिंग चल रहा है, मेरे को पता नहीं। पहले से ही हैंग है इसका। बुलाया था, हो गया 6:30। वो शायद अंकोना के साथ गया, वो आ जाएगा शायद, आ जाएगा टाइम पे। इसको कैसे ऑफ करना है ये मेरे को समझ में नहीं आता है, तो फिर से डिबग भी करना है मेरे को। भाई इसको छोटा कैसे करते हैं पता है तेरे को? इसको स्क्रीन से बाहर आना का कैसे करता है इसका कंप्यूटर? मेरे को अभी भी लैपटॉप को समझ में नहीं आता है
क्या?
हाँ, ये
चल तो रहा है।
OBS स्टूडियो है, उसको स्टॉप रिकॉर्डिंग करना है।
जाओ बेस में स्टॉप रिकॉर्डिंग कर।